Okay, so we were doing Ohm's law, okay, and we have established that that current, the Ohm's law says that current is directly proportional to your potential difference, right? So I is directly proportional to your potential difference at a constant temperature. And we will look into that, what will happen if we increase or decrease the temperature. Right now, at a constant temperature, the current flowing through the conductor is directly proportional to the potential difference across its ends. Okay. Um, sorry. You have to remove it every time. Okay, so V is directly proportional to I, and we have a proportionality constant, that is R, which is resistance. So it says that V, the ratio of potential difference and the current will always be a constant, and
Resistance.
that constant is resistance. This is another analogy of the same thing. For example, instead of electric current, we have a water current, and it is falling from a cliff. So this free fall, this is what established by your potential difference. This is also considered as a potential difference. Why? Because see, if you have a, okay, it's difficult to use both annotations on the slides. Right. So for example, if you have a ball, right, at some height, can you say that this ball has a potential? This ball has a potential to reach ground? Yes,
Yes.
because it has some energy that is called potential energy. So that means it has some potential to reach ground. Similar thing, and this potential will increase with respect to height. The more the height, more is the potential. Can we say that? Yes.
Yes.
So similarly, you see here, there is a dam here and there is a water. So that current is depending upon now the potential. And that potential is, that means this height. More the height, more the potential. And there is a block here, okay, which is acting as a resistance here. How? If we move this block, again I have to remove annotation. Yeah, sorry. See, if we move this block below, the current, this current, that means this flow of water will decrease, right? So it is acting as a resistance, and this height is acting as a potential, or this length, this height is also acting as a potential, because more the water up from this region, more far will this flow will go. Okay, so this is another analogy to study your Ohm's law. Are you getting this? So
Yeah.
more the potential, more the current, and this block is acting as a resistance. So if we make it down, so that means if we increasing the resistance, resistance means obstacle. So if we are increasing the obstacle, the current is decreasing, no matter whether your voltage, whether your potential difference is same or not. Okay. So similarly thing happens at the circuit. Okay, similar thing happens with the your Ohm's law. See here in this graphics. Okay, so this is a potential which is pushing the electrons to flow from a conductor, and there is an obstacle. This guy is acting as an obstacle. It is increasing the it is decreasing the flow of current. So if this increases, that means if resistance increases, that flow will decrease. Okay. So this is the analogy to understand the Ohm's law. And this we have also discussed that if we double the voltage, we will have double the current. If we have double the resistance, we will have half the current, right? This you can see from here, right? It is directly proportional to your voltage and inversely proportional to your resistance. So any doubt from here? I think it's just a recap from what we have done in the previous class.
Yeah.
Now today we will study about this resistance. It depends upon length of conductor, thickness of conductor, the what is the material, whether it's conductor, insulator, or semiconductor, you can say, or different conductors have this will have the different resistance and the temperature. Okay, so we will study it one by one, how it is affecting your resistance and why it is affecting the resistance. Yeah. So before going forward, this is a one more point. So we know, okay, I'm looking to clear this rise now. So we have seen that there is a relationship between your potential difference and current. And what is that relationship? This relationship is linear. Okay, what do you mean by linear? What do we mean by linear? Can you say in terms of mathematics? Okay, linear is something that means the relation is you can say one to one, or you can say that, for example, we have seen that ratio is constant, right? V by I is your constant. Okay, the linear relationship, if you say mathematically, it is something like that. So you have studied some equation like this, linear equation. This thing you have studied or not? Have you seen this equation before?
Yes.
Yes. What does it say?
It tells us that a variable is equal to a constant plus a variable
Not
value.
constant. It says this is variable and this is also variable. Okay, we have two variables. This is called dependent variable and this is independent. That means y is depending upon x, right? If you increase the x, the y will increase, right? Or decrease depending upon these value of m and c. This relation is saying that this is linear. How? Because if we represent this graphically, you will get something like this. If let it make me more specific. Okay, let's say y equals to mx. Okay, if you represent this graphically, it will start with 0. So this is your x-axis and this is your y-axis. If you want to draw a y equals to mx equation, you will show a straight line. You will see a straight line. Yes, you will see a straight
Yes.
line. This is what we mean by linear. So we say this relationship is linear because there is a linear relationship between y and x. Okay, but if I have equation like y equals to mx square, then when I try to make a graph out of it, I will see a parabola. Okay, now this is not a linear, this is non-linear. You getting this point? So we have
Yes.
a relationship. So now if I ask you, if I'm saying v equals to I into r, and if I draw a graph between v and I, what will can you compare this thing and this? These are same, this is similar, right?
Yes.
So if this is linear, that means this is also linear. So when I draw a graph, I will see a linear
Straight
relation.
line.
Okay. Generally, we take y-axis as a current and x-axis as a potential. Generally, okay. But you can do it either ways. Okay, it doesn't matter. Now this slope, it will tell you about the resistance R. This slope here, it will give information about M. Similarly, this slope will give information about resistance. Okay, how? We'll see. This thing is clear up to now. This relationship is linear thing is clear.
Yes.
Yes. Okay. Now, if you now come to this graph, okay, this is voltage, this is current. Okay, this I'm saying will this slope is telling us about resistance. How? So for example, take this point. At this point, we have some value v, and at this point, I have some value I, right? So what is the value of this I?
Yes.
This length of AB. Yes. This AB is the magnitude, right?
Yes.
So this I is AB. So this is equal to this because these are kind of rectangle, right? So if this is I, this is also I, right?
Yeah.
So I can say, so if you see this as a right angle triangle, right? This slope is perpendicular upon base. This we have studied in trigonometry,
Yeah.
or yet to study. I don't
Yeah.
know. Yeah, studied. Yes. So this perpendicular upon base will give you about slope, right? And what is this
Yeah.
perpendicular? Current. And this base is,
Your voice is not clearly audible. It's breaking in between.
today my net is little slow. Am I audible now?
Yeah.
I think okay. I will keep my mic on hand. So I'm saying this this slope is your perpendicular upon base, and this perpendicular has the magnitude of current, and this base is the magnitude of voltage. So what is I by v?
Voltage.
This is a constant, and you can say
Resistance.
this is 1 upon resistance. Okay, this is just a constant number, so it doesn't matter if I write r or 1 by r. It will just it will still remain a constant. It still will tell you about your resistance. You getting this thing?
Resistance. Yeah.
Yeah, because if I say, if I have v here, I here, then I can have said that v by I is r, right? Now because this is I'm
Yeah.
using as current and this is voltage, so this is 1 by r. Okay, or you can just say that it will be always a constant. Again.
Yes.
Okay. So moving forward. Now there is an experiment to verify the Ohm's law. Okay, so we have a circuit, right? So can you identify this circuit? This is your cell. Yes, this is the connecting wires. You have put an ammeter. Ammeter you put always in a series. This is in series, yes. And there is a conductor from
Yes.
which we want to verify the Ohm's law. Okay, because in Ohm's law what we are saying if we have a conductor, and if I apply some potential difference, so if I apply some potential difference, right, and I measure the current, I will say if I increase the potential difference,
Yes.
the current will also increase. That means a linear relationship. Now, so it means that V by I, again it is, so V by I is your constant. Is my screen lagging at your end?
Yeah. It's not like your screen is frozen.
I think it's a heating issue. Let me just put it something. Is it better now?
Yes.
At my end, it's the same issue. So we want to verify the Ohm's law, and to verify the Ohm's law, it's not working. To verify Ohm's law, we want this ratio to be constant, right? So, so we made this circuit. In this circuit, we have a battery and an ammeter connected to it. and this is a conductor which have some resistance, and we know to measure the voltage we need a voltmeter, so we put a voltmeter across the resistance, right? And also we have a rheostat.
Yes.
What was the rheostat? You remember from the last class?
Variable resistance.
Variable resistance. And why do we need a variable resistance here? Because to verify Ohm's law, we want to see that if I increase, because the relationship is I is directly proportional to V, right? So we want to see if we increase I, the voltmeter also gives the higher reading or not. Okay, so that's why we are putting a rheostat. So how exactly we are doing? First, we will switch on the circuit and put some rheostat value. Okay, it will give some. Okay, now this circuit is complete. Yes, ammeter will also give you some reading, and
Yes.
voltmeter will also give you some reading. And what are these reading? Ammeter will give you a reading that what is the magnitude of current flowing through the conductor. Yes, because it is
To
connected to the
the
series with the
conductor. Yes.
resistance. Yes, with the conductor. Yes,
Yes.
and voltmeter will give you what is the potential difference across the conductor. Okay, this
Two
thing is,
ends of the conductor.
yes, across the ends of conductor. Now after making a switch on, let's say I got some value of I, let's say I1, and also we got some value V1. Okay, now because this is a variable resistance, now what happen if you increase the resistance of a rheostat? The current value will decrease.
Yeah.
Yeah, so let's say it decreased to some point I2. Now this voltage will this voltmeter will also give you some different reading. Now
Yes.
let's say it will give you V2. Now do it again. Okay, increase the value of resistance. You will get some another value I3, which is less than I2 because you have increased the resistance. Again, you will get
Yes.
some reading V3, and so on. You can do that, or you can increase or decrease the rheostat. You will get higher value of current. Now take 4, 5, 10, or whatever is your satisfaction value. Take all these reading and calculate. To verify Ohm's law, what do we need? We need to establish that the ratio is constant. Okay, so what do we need? That I1 by V1, calculate all these value. I2 by V2, I3 by V3. Again, it's frozen. Okay, so calculate all this ratio and see if they all are equal. That means the ratio will always be constant no matter what. That means Ohm's law is verified.
Verify.
Okay, easy. समझ में आएगा कि मतलब सेटअप कैसे
Yes.
करना है और हम एग्जैक्टली कर क्या रहे हैं, राइट? वर्किंग तो हमें एस्टैब्लिश करना था Ohm's law मैथमेटिकली मींस रेशियो इज कांस्टेंट, एंड वी आर जस्ट एस्टैब्लिशिंग, वी जस्ट हैव एस्टैब्लिश्ड uh, by decreasing increasing various value of current, and we calculate we took the reading of voltmeter from the corresponding current, and we took out the ratio, we calculate the ratio, and this ratio happened to be constant. If this is constant, that means Ohm's law is verified. Okay.
Yes.
Okay, moving on. It's trying remove the annotation, and okay, now let's come back to our whiteboard. I think I might need it. I think I haven't switched off my laptop from past 3 months. That's why it's hanging. I have to restart. Okay, this could be a problem. Okay. Anyways, So Ananya, can you tell me now what are conductors? What is the difference between conductor? Oh, it's not working. So what are the conductors? In terms of resistance, can you say anything about conductors?
Your screen is blank, it's not visible. I mean, I can hear you, but I can't see anything.
Oh. Can't you see any white screen or it's still slide screen?
It's still the slides visible to me.
Okay, let me know if you see the whiteboard.
Yeah.
My screen, it is showing the whiteboard and it seems to be fine. I guess it's a connectivity and as well as heat issue. Okay, and if I'm audible, can you tell me what are conductors in terms of resistance?
They would have low resistance to allow easy flow of current through
Right.
them.
So not only low, it should be very, very low. So those who have very low resistance, so those substances which have very low resistance, uh, we say are conductors, right?
Yeah.
And insulators,
Insulators have a very high resistance.
very high resistance, good. And so I'm writing these things, so I don't know. You still, the screen is still not visible, right?
Now it's visible.
Oh, okay, nice.
Just right now, I said.
Okay, good. So conductors very low resistance, insulator very high resistance. There is third thing that are that is resistors. What are resistors? So resistors is something which have the resistance uh, greater than comparatively very high than conductors and comparatively very low than insulators. Okay, there's those substances we will use as resistors and we call them as resistor also. Okay, and these forms like examples are metal alloys. Okay, the resistor you see in your power plant, power stations, or in your home or in the labs. Okay, these are those have the resistance which is comparatively high than your conductors and lower than your
Lower than
insulators. Okay, why? Because we need something. We don't need something which is if I give very
completely blocking the flow of current.
yes, yes. It should be. It should not be like that. It can, if we give a very low potential, it just go from one point to another. That means currents just start moving. We don't need something like that, and we also don't need something that we give so much high potential, and then only it just move very little. We don't want that also. We want something of intermediate between these two to
Medium value.
make the electric circuits work, to make bulbs and to make various things, and that are so that is something we need, and that category we have named resistor. Okay.
Yes.
Okay. So now come to the main topic, today's main agenda, that we have to that are factors affecting resistance of conductors. So like in slides, we have four factors. What are those? Length,
Length, and then uske baad we have
area, area of cross section of conductor. Okay. Third,
Area, nature of material,
material from which conductor is made, and temperature.
thickness, or maybe
Okay.
temperature. All right,
Thickness
temperature.
you have already covered mm, in area also. Why? Because okay, here I can say if this is a conductor, that's a road, conductor road. Okay. So this you will consider as a length. Which thing you will consider as a length? Across which you are applying the potential difference. Okay, always remember, because we can say anything as length and breadth and height, right? So along which we are providing a potential difference, that we will say as a length, that we will consider as a length. Okay. And that cross section area, okay, that area from which electrons are flowing, okay, so that we will say your cross section area. So here it is, this is area. Are you getting this thing?
Yeah.
Okay. And third is nature of material, and fourth is your temperature. Okay. So how length is affecting? So first thing, how length is affecting? This you tell me yourself. I will give you two scenario. Okay. I have a one rod of length, let's say 5 meter, and I have another rod. Let's say, I don't know comparatively it's double or not, but let's say it's 10 meter. Okay. So we know that we're just talking about obstacles, right? If we talk about resistance, that means we are talking about obstacles. So in which scenario the electrons will flow easily? Here electron is also flowing. Here is electron is also flowing after providing some potential difference. So in which scenario it is easy for the electron to move?
Where the rod is shorter because it will take lesser time for them to pass through.
Lesser time. I don't think time is a constraint here. Why? Because as soon as you apply the potential difference, I've told you earlier also, it's not just the electron going from here and another. It's electrons are everywhere. Yes, right. So as soon as you apply the potential, this electron will also start flowing. This electron will also start flowing. This also. Okay. But the problem with doubling the size of road is that this one will be much more crowded, because more length means more crowd of electrons, right? More atoms are there,
Yes.
more electrons are there. So you can think in this scenario.
Create more obstruction.
Yeah. So this abstraction is due to the more crowd. Okay, not time. Okay. So we have more electron clouds or electrons are here, okay, which will provide obstruction to each other. So that is the reason, not the time. Okay. So typically this we have seen experimentally. If you increase the length, okay, it increase the resistance. In how much proportion? It is also the linear relationship. That means it is directly proportional to your.
Directly.
So if you go from L to 2L, that means if you double your length, your resistance will also get doubled.
Double.
Is it clear? So R is
Yes.
directly proportional to your L. Longer the wire, longer the resistance. Now comes to the area. Now again think, okay, while giving these answers or while discussing this thing, okay, always think about how electron is behaving, okay, in this scenario. So I will give you two scenario again. One, I have an area A, and other I have a double area, okay, and we have electrons. In which scenario it is easy for the electron to pass? Which one will give the easy passage? This one or this one?
One with the larger area.
One with the larger area. Why?
Because it will create more space.
Yes, it will create a more space. Okay, they have the, so in earlier case the crowd was more. Now here space is more. If you have space is more, that means you can easily pass on because we are applying the potential difference across the ends. Okay, if in this area, if I apply the potential difference here, now electron will start move from here to here, here to here. This also will act as a length because more distance has to cover and more crowds are there, right? But in this scenario, uh, because every electron has goes from this end to this end, if you're increasing the area, that means now you have a larger space to pass on. It can move from here also. Now it can move from upper part also if you increase the area. Okay, right? So
Yes.
here resistance is inversely proportional to your area. Okay, this is
Yeah.
also a kind of inverse linear relationship that you can say. So that means if you go from area to two area, twice of area, your resistance will get half. Okay, and if you go from uh, okay, if you go from fourth time of area, your resistance will go 1/4. Got it?
Yes.
Okay. Can you do a simple calculation for me in mind also only? Okay. If you want, you can use a pen also. Um, Suppose you have a wire. Okay. So wire is cylindrical. You have a cylindrical wire. So wire is like this. So you have given a diameter. You have given a diameter d. Okay. If I increase this diameter, that is, if I go to 2d, for d, let's say I have a resistance R. Now question is, what if I double the diameter? What will be the resistance in terms of R? Will it double? Will it quadruple? Will it be half? Okay. So your options are: will it be 2R? Will it be 4R? Will it be R by 2? Or will it be R by 4? Can you do that for me?
Yeah, just let me do it once.
Take your time.
It will become half. Resistance will become half R by 2.
And why is that? How come you come to this?
Because resistance is inversely proportional to area. So if lesser the area, higher the resistance. So if area is increased, then resistance will decrease.
So what do you think? What happened to area? Area becomes half.
Area, you said area increase, so resistance will become half.
So I'm asking: is in this scenario, is the area become doubled, or what is the area here in first
Its
scenario? You are saying that
screen is frozen again.
am I audible?
You're audible, but your screen's frozen again.
Okay, I'm just asking. You are saying that its resistance will become half. Okay, so indirectly you are saying that its area is doubled. Yes.
Yes.
So I'm asking, how can you say that area is doubled? What is the area in the first scenario?
It's the diameter, and second is 2D, means you have
Yes.
doubled the diameter.
I've doubled the diameter, but the area becomes doubled.
It'll increase.
It is increased definitely, but how much? See, in first example, you know the area of cylinder.
Yes,
What is the area of cylinder?
it's 2 pi RH and then the bracket R plus H.
Okay. The at the end we have a circular region, right? So what is the area of circle? It's pi r square,
Yeah.
right? Because it's cylinder, right? So we have a circular region, and that we have increased that in terms of diameter. So what is the area at the end? We have pi r square, and in terms of
Hmm.
diameters we have pi d square by 4. Yes, because r is diameter
Yes.
by 2, right? So it's pi d square by 4. Yes or no?
Yes.
Now we have increased the diameter. So what will be the area now? Pi 2d whole square by 4. Yes.
Yes.
So what is the area? It will be pi 2 square 4. 4 से 4 cancel हो जाएगा. Then it means pi d square only.
Yeah.
I'm saying this is a prime, the other area. Okay. So what is the relation between a prime and a? If you divide a prime by a, you will get.
It's not visible again. Your voice is plus breaking.
Oh, I'm saying not the new area becomes pi d square, right?
Yes.
Okay, and earlier it was pi d square by 4.
Hmm.
So that means area becomes 4 times.
Yes.
You see, if you divide these two, you will get 4. That means area becomes 4 times, not double.
Yes.
So if area becomes 4 times, that means your resistance will become 1/4
R by 4.
r by 4. Okay, so answer is r by 4. Got it?
Yeah.
Okay, so in this type of okay, always remember to calculate area first. Okay, I've increased the diameter, so it's not the same like you are increasing the area by same proportion. Okay, so these kind of question you will get in exam also, and this is very important question. Okay, this has come into CBSE various time. Okay, so it's 2 mark question. Okay, is clear?
Can you explain that cylinder portion again once?
Okay, I'm explaining it on new slide. Okay, so I okay, the question in the question nothing is written about cylinder. Okay, it is given a wire. Okay, so when we talk about wire, we assume that it is like cylinder. Sometimes it's written, sometimes it's not. Okay, so now let's say I have given you cylindrical wire to not to confuse. Okay, cylindrical wire. So how does it look? So we have a cylinder, that means we have a circular base and the elongation of that, right? So it has some
Yes.
length and it has some, and we have given the diameter. Sometimes you will give radius and this will give you the same result basically. So we have a diameter d. Okay, the question was, if you double the diameter, the question was, if you double the diameter, how much times the resistance will increase? Okay, so question was, how much resistance will increase? So you will say, you will start by like this, say let r be the resistance, r be the resistance
Yes.
when diameter was, when diameter is d,
D.
when d is diameter or diameter is d. Okay, okay, so in first case, so what is the area when diameter is d? It is pi r square, that means pi d by 2 square whole square, that means pi d square by 4. This is clear?
Yeah.
Okay, so we are saying let a be the area in first case. Okay, we have calculated. Now in second case, let A prime be the area when diameter is 2D.
Yes.
So what is the A prime? Pi some, okay, we can do it directly, right?
Hmm.
Pi 2D whole square by 4.
Hmm.
Okay, so if you don't want to do it one step, you can do it slowly also, so that you don't miss anything. So again it is pi r prime square, or when the diameter anything, so you know the area, let's say r prime square, and r prime is your 2D. No, don't write that. Right. So we know that it is pi r prime square. That means pi d prime square by 4. And we have d prime is, for the new area, we have 2D, diameter twice. So you can write
Yes.
2D whole square by 4.
Yeah.
And you simplify, you will get pi d square. Okay. So the ratio is a prime by a. You divide this thing, you will get 4. Okay, right? And
Hmm.
we know that r is inversely proportional to your area. Okay, so
Hmm.
if r prime is new resistance, okay, तो इससे हम क्या लिख सकते हैं? r prime by r equals to a by a prime. Yes.
Yes.
So
Equal because they're equal.
r prime by r equals to a prime by a 4 है, तो इसलिए क्या है? a by a prime, that means 1 by 4. That means
Yes.
r prime is r by 4.
Hmm.
Okay, don't stop this answer here also, because the question was only in terms of statement. So write the full statement afterwards, that if so the resistance will be 1 by 4th of original resistance. Okay,
Yeah.
and if you want to elongate, if when you increase the diameter, this only up to you. Okay, so this is how you do your calculation, whole calculation. Okay, you can do it in one line only if you have habit of saying things. Okay, and this come with only practice. And if you want to explain everything, this is how it can be done. Okay, तो इससे प्रॉब्लम, इससे इजी क्या होता है कि हमें कोई भी चीज स्किप नहीं करते. ओके, जैसे आपने हर चीज स्किप कर दी थी. जैसे मैंने बोला कि आप एरिया को ट्वाइस कर दो तो आपका रेसिस्टेंस हाफ हो जाएगा, है ना? तो आपने
Hmm.
सीधा एज्यूम कर लिया, ओके, बिकॉज ये डायमीटर इंक्रीज कर रहा हूँ तो वो भी उतना हो जाएगा, कर दोगे. बट जब आप एक्चुअल कैलकुलेशन करोगे, यू विल सी थिंग्स डिफरेंटली. ओके, क्या क्या आप स्किप कर रहे हो. तो ऑलवेज ट्राई टू बी एज थरो एज पॉसिबल इफ यू हैव टाइम. ओके, दिस क्लियर नाउ?
Yeah. Hmm.
So third thing, I don't think we need to elaborate on this. Okay, it obviously it depends on nature of material, because some material have low resistance than others, some has higher than others. Okay, right?
Yes.
And it all depends upon the atomic property, basically atomic
Hmm.
property of each material. So this is understood why nature of material is different. And the fourth thing is temperature. Yeah, this is interesting. This is interesting. Why? For pure metals like iron, gold, copper. Okay, if you increase the temperature, Okay, resistance will also increase. Can you think again in terms of obstacles? What will happen? Because pure metals are conductors, yes. So there are
Yeah.
already the free electrons are there.
Hmm.
Yes. So they are already randomly moving. Now, if you increase the temperature, what will happen?
If the temperature is increased, the atoms will also start moving around.
No, atom, no, atom won't have much effect on this thing. Okay. Uh, Tell me only in terms of electron. What will happen to electrons if you increase the temperature?
They'll start moving faster.
They start moving faster. That means the collision will also increase. So you're
Yes.
saying that if you increase the temperature, they will start moving faster, and
Hmm.
moving faster means they will the collision.
Collide with each other.
And if collision increasing, that means resistance increase. Okay. Now, if you think in terms of resistors, resistors are what? Somewhat intermediate between conductors and insulators. Yes. So, for example, metal alloys like uh, like nichrome. Okay. So, so if you increase the temperature, I think actually there is a detailed discussion on this thing. Okay, because it has some different effects on different resistors. Some in some cases, if you increase the temperature, the resistance will somewhat unaffected. Okay, I will tell you why in what case. Okay, and in some cases it drops. Okay, why? Because again, think in terms of moving, collision, and obstruction only. Because in resistor they are not as easy flowing as in the first case. Yes. So if they are
Yes.
bounded, very hard, so this increased temperature will give them some freedom, because they will give some energy, and this bond can be broken. This proton and electron attraction bonds is broken. Okay, or you can say
Yes.
weaker. Then it will start more flowing more easy than the previous case. So अगर ऐसा होता है तो उस केस में क्या होगा? रेजिस्टेंस ऑलरेडी डिक्रीज हो जाएगी, क्योंकि अब वो पहले से ज्यादा अच्छे से मूव कर पा रहे हैं, है ना? और किसी
Yes.
केस में ऐसा होता है कि ये मूवमेंट इतना इफेक्ट करता ही नहीं है उसको, वो पहले भी उतना ही से कर रहे थे। तो समझ लो, दो चीजें हो रही है टेम्परेचर इंक्रीज करने से, दो चीजें हो रही है। एक हो सकता है आपके कोलिजन बढ़ रहे हैं, राइट, और जो कोलिजन बढ़ने से क्या हो रहा है? रेजिस्टेंस इंक्रीज हो रही है। और दूसरे केस में क्या हो रहा है? फ्रीडम बढ़ रही है। ओके, तो फ्रीडम बढ़ने से क्या हो रहा है? वो बॉन्ड थोड़ा वीक हो रहा है, तो रेजिस्टेंस डिक्रीज हो रही है। तो समझ रहे हो, ये आपस में एक दूसरे से लड़ रहे हैं। तो रेसिस्टर भी डिपेंड करता है कि कौन सा मटेरियल है, क्या है। तो वो हो सकता है वो एक दूसरे को नलीफाई कर दें। जब वो एक दूसरे को नलीफाई कर देंगे तो वो अनइफेक्टेड हो जाएंगे। हो सकता है पहला वाला ज़्यादा डोमिनेट कर जाए, तो आपकी रेजिस्टेंस डिक्रीज हो जाएगी। सो इसलिए मैं बोल रहा था, ये थोड़ा डिटेल्ड डिस्कशन होता है, इस पर तो बहुत रिसर्च पेपर्स हैं, बहुत रिसर्च होती है कि कैसे इस चीज़ को इफेक्टिव बनाया जाए। तो अगर अभी आपके एग्जाम पॉइंट ऑफ व्यू से बोलूँ तो दिस इज इम्पोर्टेंट कि आप प्योर मेटल में जब आपका टेम्परेचर इंक्रीज करेगा तो आपका रेजिस्टेंस इंक्रीज करेगा। तो इसका तो आपको रीजन भी मिल गया। यस,
Yes.
ठीक है। दूसरे केस में आप कह सकते हो इट इज अनअफेक्टेड। इससे ज़्यादा बोलने की जरूरत नहीं है। अगर ऐसा कोई क्वेश्चन आता है तो वैसे हार्डली आता है, बट आई डोंट नो, मेरे को भी देखना पड़ेगा। लेकिन अगर आता है तो आप कह सकते हो फॉर द सेफ साइड दे विल रिमेन अनअफेक्टेड। ओके,
Yeah.
यहाँ पे कोई डाउट?
No.
So next thing is your yes. So अभी तक हमारे पास क्या क्या आ गए? 2 पॉइंट्स आ गए। तो जो बेसिकली फिजिकल डायमेंशन पे जो डिपेंड कर रहा है रेजिस्टेंस, दैट इज योर लेंथ एंड योर एरिया।
Area.
यस, तो ये चीज़ तो एस्टेब्लिश है। टेम्परेचर और बाकी चीज़ें तो इसमें डायरेक्ट नहीं आ रही है ना। तो अगेन अगर मैं इस प्रोपोर्शनैलिटी कांस्टेंट को इसको प्रोपोर्शनैलिटी साइन को हटाऊं तो मेरे को आप यहाँ पे क्या डालना पड़ेगा, एक कांस्टेंट डालना पड़ेगा। अगर मैं इसको इक्वल टू
Yeah.
करना चाहता हूँ तो देन आई नीड अ कांस्टेंट। ओके, तो इस केस में इस कांस्टेंट को बोलते हैं रेसिस्टिविटी, और इट इज कॉल्ड रेसिस्टिविटी।
Resistivity.
अगेन इसकी 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 ऐसा यूनिट क्या थी, ओम, इसकी मीटर, और इसकी एरिया की मीटर स्क्वायर। यस।
Yes.
तो अगर मैं आपसे पूछना चाहूँ व्हाट इज द डायमेंशन ऑफ रेसिस्टिविटी, तो क्या हो जाएगा, क्रॉस मल्टीप्लाई, एरिया से मल्टीप्लाई, लेंथ से डिवाइड, मीटर स्क्वायर से मीटर कट जाएगा, तो आपके पास क्या आ जाएगा, ओम मीटर। यस।
Yes.
तो ये आपकी ऐसा यूनिट होती है रेसिस्टिविटी की। तो अगर मेरे को डिफाइन करना हो अगेन हम किसी भी चीज़ को डिफाइन करते हैं तो किस तरीके से करते हैं। अगर मैं रेसिस्टिविटी बाकी सबके टर्म्स में लिखूं तो कैसे लिखूंगा, आर ए बाई एल।
Yeah.
ठीक है। तो अगर मेरे को डिफाइन करना हो व्हाट इज रेसिस्टिविटी ऑफ अ सब्सटेंस, तो मैं क्या कह सकता हूँ, दैट रेसिस्टिविटी, अगर मैं इसको 1 लिख दूं और इसको ही 1 कर दूं तो रेसिस्टिविटी रेसिस्टेंस के इक्वल हो जाएगी।
Yes.
इफ एल इज योर यूनिट and area is 1 meter square, then your resistivity will be equal to resistance. Okay, तो मैं
Yeah.
कैसे डिफाइन कर सकता हूँ resistivity, then resistivity of a substance is numerically, okay, this is important because हम ये जब भी इस तरीके से डिफाइन करते हैं 1 1 करके, that means we are saying only in terms of numerics, तो it is numerically equal to
Equal to the resistance.
the resistance of substance which is 1 meter long
1 meter long and one
and
meter
1
wide.
meter square cross sectional area, right? Cross section.
Yes.
This is how we define resistivity. Now okay, ये again जैसे हमने करा था कि R equals to V by I, yes, तो हमने देखा था ये
Yes.
कांस्टेंट जस्ट आया है, इसका मतलब ये नहीं है कि रेजिस्टेंस इस पे या इस पे डिपेंड करता है, इट इज नॉट डिपेंडिंग अपॉन V एंड I। सिमिलरली आपका जो रेसिस्टिविटी है वो ना ही आपके एरिया पे डिपेंड कर रही है ना ही आपके लेंथ पे डिपेंड करती है। ओके, ये किस पे डिपेंड करती है, इट डिपेंड्स ऑन नेचर ऑफ मटेरियल, इट डिपेंड्स ऑन नेचर ऑफ मटेरियल।
Nature of material.
तो अगर नेचर अगेन कंडक्टर के केस में रेसिस्टिविटी आपकी कम हो जाएगी क्योंकि ये रेसिस्टेंस के इक्वल आ रहा है ना न्यूमेरिकली, तो
Yes.
रेसिस्टिविटी इज लो इन
In
कंडक्टर्स
conductor.
एंड हाई इन इंसुलेटर।
Insulators.
ये बात क्लियर हो रहा है?
Yes.
ओके, और ये आपका टेम्परेचर पे भी डिपेंड करता है, तो वो जो दो चीजें हमारी मिसिंग थी वो वापस आ गई है ना, ये टेम्परेचर पे भी
Resistivity.
क्योंकि हम रेसिस्टिविटी यहाँ पे वही प्योर ऑब्स्टैकल पे डिपेंड कर रहे हैं। ठीक है, हम ना एरिया पे डिपेंड करा रहे हैं ना लेंथ पे, हम प्योर एटॉमिक स्ट्रक्चर पर आ गए हैं, और किस तरह से उसकी टेम्परेचर कॉन्फ़िगरेशन है, किस टेम्परेचर पे उसकी कैसी एटॉमिक कॉन्फ़िगरेशन है उस पर डिपेंड करता है। तो दैट मीन्स जो आपका रेसिस्टिविटी है इन शॉर्ट नेचर ऑफ मटेरियल और टेम्परेचर पे डिपेंड है। ओके,
Yes.
राइट। तो यहाँ तक कोई डाउट?
Resistivity is also dependent on temperature along with nature of materials,
यस
right?
यस यस। ओके तो जो मैं कह रहा हूँ टेम्परेचर पे डिपेंड कर रहे हैं, तो जब भी आप रेसिस्टिविटी डिफाइन कर रहे होगे, मतलब लेट्स से कि मैं बोलूँ रेसिस्टिविटी ऑफ ऑफ कॉपर, और ये एक्चुअल नंबर है 1.69 इंटू 10⁻⁻8 ओम मीटर। तो आप देख रहे हो कितनी कम है बेसिकली, फर्स्ट ऑफ ऑल, ठीक है। तो जब मैं कह रहा हूँ रेसिस्टिविटी ऑफ कॉपर इज 1.69 इंटू 10⁻⁸ ओम, मेरे को यहाँ पे स्पेसिफाई भी करना पड़ेगा कि किस टेम्परेचर पे बात हो रही है, ओके, क्योंकि ये टेम्परेचर डिपेंडेंट है। आप टेम्परेचर चेंज करोगे तो आपकी ये वैल्यू भी चेंज हो जाएगी। तो ये जो नंबर है आपका आता है नॉर्मली 20 डिग्री सेल्सियस, ओके। तो आप कोई भी रेसिस्टर मार्केट से लेते हो या लैब के लिए कुछ लेते हो इंस्ट्रूमेंट, तो अगर उस पर रेसिस्टिविटी लिखी है तो वहाँ पे जरूर मेंशन होगा कि वो किस टेम्परेचर पे लिखी है, ओके, वो आपके यूजर मेन्यू में लिखा होगा।
ओके
तो रफली जो मेटल्स या कंडक्टर्स, ठीक है, इसकी जो रेसिस्टिविटी होती है वो जनरली आपकी 10⁻⁸ की रेंज में होती है ओम मीटर, ओके। उसके बाद आप कहते हैं रेसिस्टर, बेसिकली सेमी कंडक्टर्स, है ना, मेटल अलॉयज या फिर, तो सेमी कंडक्टर्स आपके आते हैं कुछ इसकी रेंज को जहाँ तक याद है
-6 की रेंज में है।
-6 की रेंज में,
यस
कहीं मैंने रेंज पढ़ी थी, मेरे यहाँ पे नोट्स में है नहीं। और हमारी जो
49
इंसुलेटर्स हैं, कोई नहीं, वो तो नेट से देख लेंगे, नहीं तो मैं नेक्स्ट टाइम बता दूंगा एग्जैक्ट रेंज। ये बहुत हाई होती है, आई गेस ये होती है आपकी 10⁻10 से 10⁻18 16 18 तक भी होती है ओम मीटर। और ये कुछ मिड रेंज में होते हैं, मे बी शायद 10⁻⁻4 और -2 से सम फ्यू हंड्रेड ओम मीटर, रफली ये रेंज होती है, आगे पीछे हो सकता है, ठीक है। तो दीज आर द मीटर्स, शायद 4 होगा, these are not the exact number, this is just range, ये और ये भी रेंज थोड़ा आगे पीछे ही है। तो जस्ट गिव यू आइडिया कि देख रहे हो कि मतलब कितने फैक्टर्स का डिफरेंस आ जाता है आपका इसमें इसमें और इसमें, है ना। सो ये चीज़ मैं यहाँ पर मेंशन करना चाह रहा था, ओके। तो एक न्यूमेरिकल कर देते हैं, आई गेस टाइम भी हो गया, तो एक न्यूमेरिकल कर लेते हैं इस पे और then we'll give it a rest. We have a sample problem. थोड़ा सा टिपिकल कर लेते हैं। So we have a copper wire, okay, which has diameter 0.5 mm and resistivity 1.6 into 10⁻⁸ ohm meter. Okay, so question is, what will be the length of this wire so that my resistance is 10 ohm?
Can you repeat the question again?
So you have a copper wire and this wire has a diameter 0.5 millimeter, okay, and resistivity is 1.6 into 10⁻⁸ ohm meter. Question is, what should be the length of the wire such that resistance is 10 ohm?
Okay, just give me a minute. I'll
Yeah, sure. Take your time.
It will be 1 to 2.72 meters.
Precisely, right. You got the point, right? You have to calculate the area, which is pi d square by 4, and distance is given, which is 10 ohm. Length you have to calculate.
Yeah.
Resistivity
So
is
we'll
given. Put
transpose
it
the
in.
length that side and resistivity here.
So just put it in the formula and you will get the unknown. Okay. And what happens if I double the diameter?
Double the diameter.
What will happen?
Resistance will decrease to
By
2.5 ohm.
how many times?
I'm sorry, I couldn't hear you clearly.
I'm saying what will happen if we double the diameter? What happens to your resistance? Will it decrease? And if it decrease, by how much? This we have already done, right? So if we double the diameter, the area will become 4 times.
Yeah, I have taken it out, but I can't exactly pinpoint by how much. I have got an answer for that.
By how much? This we have done, right? We just have done. If we increase the diameter, the area will become 4 times of area. Yes. And we have this inverse relation with the area.
Yes.
That means the resistance will become
Yeah.
1 by 4th.
I calculated the area. I got the answer, but I didn't actually totally remember the by how much.
Okay,
I
I
just
can show you this slide again, where we have done this calculation. It's the same calculation.
yeah, yeah. I
Okay,
got it now.
okay. Just have a quick revision from this slide also. Okay. So see, this question will come again and again with different form. Okay, this diameter one. You got this one, or should I explain it once more?
No, I got it.